Being in this space, I know I gotta hold my hold down. Seeing what it takes, I gotta know that I can show how. Questioning myself if I believe it though. No longer question if I'm really a believer though. Now you should take into account that my account.
Hello everyone, welcome to the show In Code We Trust. I am Pras Masani from Token Metrics team. Today I'm going to do a technical review of very interesting project, CasperLabs, building the decentralized future. I will be going through the technology scorecard metrics that we use at Token Metrics to validate the technology strength of this project. Little disclaimer, I am giving an unbiased technical review about CasperLabs project only for Token Metrics platform. This is not financial advice, so guys, always do your own research before making any decisions. Alright guys, so before going into any details, let's go through some of the initial screening questions, which are very important at Token Metrics. So first thing is, does this project need to use blockchain technology? I would say yes. CasperLabs is developing a fully decentralized, sharded, and scalable next-generation DAG-based public blockchain, which is Directed-acyclic-graph based blockchain rather than conventional blockchain, and is implementing the CBC, which is correct by construction Casper proof of stake protocol, and the blockchain is designed for mass enterprises, developers, and mainly for consumer adoption. In short, I would say CasperLabs is aiming to address the blockchain scalability issue by keeping the blockchain still fully decentralized like Bitcoin and Ethereum. The second thing, can this project be realized and feasible to implement? So the technology promises to scale the blockchain without sacrificing decentralization through proof of stake consensus and open and permissionless access. So the goal of CasperLabs is to create high performance multi-threaded execution environment that can enable thousands of transactions per second, solving the enormous scaling issues. So yes, I think what CasperLab is promising is something very honest and achievable goal of 1,000 transactions per shard, but still keeping the transaction cost constant with a DAG-based blockchain and implementing CBC proof of stake consensus protocols family. And the third thing, does anyone need this project? I think yes, I believe that CasperLabs can be third most trustable and fully decentralized blockchain after Bitcoin and Ethereum. So this project can serve as a foundation for the millions of decentralized businesses and applications, and it could provide a solid platform for many large enterprises need to move towards a distributed ledger technology. And the fourth question is this project protected from commonly known attacks? I would say yes, and we will go a little bit in detail about how finality and safety works in CasperLabs protocol. So in CasperLabs is open and permissionless using construct by correction algorithm, and it is written with fundamental verifiable mathematical properties to enable higher security through provable and predictable behavior. So we will see all these properties in their mathematical based white paper written by Daniel Kane. We will go over that a little bit. It's very complicated, but I will try my best to explain in this video. And regarding that white paper, we don't have white paper, but what we have is the, as I said, the paper written by Daniel Kell, the mathematic properties and hypothetical proof of each and everything, the technical concept that are available in the CasperLab protocol. So we will try to go over this as much as possible in this video. Right, guys, so let's go over the website quickly. And the list of features they mentioned, the first thing is fully decentralization. So high performance is achieved without compromising decentralization and off-chain settlement, which is very important because all transactions get final and committed on-chain only. Implemented CBC Casper Proof of Stake protocol. And this is important. There's something new in the Casper Labs is concurrency and secure execution. So the way a Casper Lab blockchain is going to execute the transactions on the smart contracts are concurrently, so they don't need to wait for each other. And they have written this multi-threaded execution engine to do that task. We will go a little bit detail on it. Efficiency and throughput. So the main goal for CasperLab is to increase the efficiency and throughput using this consensus protocol and the system-wide concurrent execution. So basically, they are claiming that rather than spending 95% of the time in solving the computational problem, like in proof of work, they can use that energy to actually doing the real work. And this is important as well because it's open and developer friendly. What does that mean is developers can write a smart contract in any language basically that is supported by WASM, so it's a WebAssembly, and it can compile into the WebAssembly binary instruction and can be deployed on the CasperLabs blockchain. So there are so many languages supported by WASM. So any of this language developers can choose and write the smart contract. Basically, the WASM is WebAssembly binary instructions which can be executed on the browser, and it is efficient and fast is because it uses the native hardware features and capabilities. And safe is because it's something similar to Java, where Java program compiles into the bytecode and runs under the Java virtual machine, as WebAssembly runs again under the sandboxed execution environment. So it's very safe. And most of the projects nowadays moving towards the WASM-based languages, then sticking with the same language or like one single language supported by their platform. For example, Ethereum, right? They just support the Solidity. If you want to write the smart contract, you have to use Solidity. But if when blockchain supports the WASM programming language, then you can write basically any language supported by WASM. All right, so let's go over CasperLabs technical specification document. Main goal for CasperLabs is scalability and throughput, right? So to increase the throughput, CasperLabs uses something called concurrent orchestration, where instead of waiting for other tasks to complete it, all tasks can be executed in parallel. And this can be done by the CasperLabs execution engine that supports the concurrent processing. So when we will be doing the CasperLabs testnet demo, I will show you, they have three different components, the node, client, and the execution engine that does the concurrent processing. And CasperLabs using the shard as I mentioned, and they are claiming to have 1,000 transactions per shard using concurrent execution of the task. So what I'm interested here is a fully decentralized, and let's go decentralized consensus. Right? So, as we know, the CasperLabs is proof of stake protocol, right? And in proof of stake protocols, there are validators, and validators are the one who propose the blocks and decides which blocks will go on the blockchain, and basically gives the vote. Right, so become a validator on the CasperLab blockchain. To start proposing the block, you need to issue a bond request to the CasperLabs blockchain, and once it gets finalized, you can start proposing the block and be a validator. Um, this is block validation life cycle. So basically, when block received by the validator, how it can determine that the validator who is sending the block is trustable, right? And the block itself is a valid. But what happens in this CasperLab blockchain is all validators do not trust with each other, right? So that's why it mentioned that fallible behavior must be assumed. So once the block is received, it validates the signature, construct the pre-state, and executes the deploy 1, deploy 2, deploy 3, basically based on confirming the cumulative for blocks with multiple parents. So basically, nodes execute this deploys in the context of the pre-state, and it calculates the hash, right, on the post state. Once that is done, it proposes the block and stores a state on the block store, right? So while each validator is doing this, it may be possible that some of the validators may not have seen this new block, right? So if we take this as an example, right, it is might be possible that this orange has not seen the B2, right, and green has not seen the B1. So this B1 and B2 do not know with each other, but the purple has seen both B1 and B2, right? And here orange has seen the B2 now because it is goes through the purple, right? And it also has seen the B3. But here purple has seen the B4, right? And green has seen the B1 because of this purple, right? But B3 but not B4 and B6 because B4 and B6 is here. So yeah, so this kind of things happen, but what CasperLabs is promising is the liveliness. That's the main challenge here, right? But eventually all of these nodes needs to come up to the consistent DAG basically, so everyone has the same information. Okay, so that's where the things becomes a complication, and one new rule come into the place, which is fork choice rule, right? So what happens here is we need to target two goals here, right? The one is validator influence the behavior of decentralized computer in proportion to their stake, right? So if you have more stake, you can influence or you have a better voting power. And the second thing is blocks that are the accumulation of a larger expenditure of the gas are preferred over those are the lesser expenditure. So that's basically what it calls the weight. Right, so if the block has the heavy weight, then that means there are so many transactions happen on that block, it can be trustable, right? And that is decided by two things, something called block score and the cumulative gas. So the block score is basically something, how many transactions happen on that block, right? If I say in like end user perspective, for example. So here, if you want to calculate the block score for B7, right, we need to just traverse the each incoming edges. So here like 75 plus 25 and then plus 50, which is 150. So the block score of B7 is 150. Block score of this B8 is 75. So 50 plus 25, so on, right? Likewise, actually, so you can see it's block score propagates all the way down to the genesis block. It's 150 in this case, right? But it can be like very, very complex in real scenarios. And the cumulative gas, this is also a very important concept in order to decide how trustable the block is, basically. Right? So in the cumulative gas, you can see the genesis block 0, then some new block came B1 with the gas is 10, then B2 gas 2, right? In the B3, if we want to find out the cumulative gas, then you need to add up all the outgoing edges here, right? Like B1 and B2, so it becomes 12. The cumulative gas is B4 is 16, is 10 plus 2, 12 plus 4, 16, all right? And likewise, and you can see, like, every time we don't need to traverse the whole graph to to calculate the cumulative gas. Is basically we can easily see that the things stored at the leaf node. So this leaf node B9 already has this 34, right? So we don't need to like go all the way to the genesis block at that time. Right, so that is about cumulative gas. So we have a graph with both block score and cumulative gas. So with both block score and cumulative gas, calculator for all blocks in this DAG. So then we can apply the fork choice rule to determine the parents. So that's the whole point of making this graph between the nodes. Right, so basically each validator nodes in the DAG can have their own perception about the overall DAG, right? So we'll end up into a situation something like this, where you can see the purple validators, orange validators, and green validators. They have a different perspective, right? Like only 150, which is the center part of all three circles, right, can see the same graph, right? Or 75 can see the graph that orange can't see. So basically, this is what happens, and eventually, the goal is the circle gets expanded, and the center bits basically keep growing, and eventually, each validators will have the same perspective about the overall DAG. Right. So basically, the more validators that have seen a block, the lower the risk that block will be orphaned in the future. Okay. And having seen a block, if validator can ascertain which other validators have also seen that block, then the validator can calculate the risk matrix for that block, right? So that means basically each validators have the same graph, and they have confirmed it with each other, right? So then they are able to calculate the risk metric, which is called the decision weight of the block, right? The higher the decision weight, the lower the probability a block will be orphaned in the future. So what I was trying to say here is some hacker wants to make a chain of block, right, without communicating with other validators in the DAG, then he won't be able to do it, because eventually those blocks will become orphaned and will be removed from the DAG. Right, guys. So now what we need to understand is how, as a validator, I know that each validators in my network has the same perception about the graph that I have, right? So in order to do that, as a validator, when I propose a block, right, I specify the most recent block that I have seen from all other validators, including myself, right? And each other validator does the same thing. Okay, so if I want to see what are the recent blocks that validator X has seen, right? He has to send me all those information, and based on the information from all other validators, I can build up the overall graph. Okay, but to do this, right, the only parent edges will not support sufficient, right? Because for parent edges, I just know that this validator is saying the block parents, right? But what other blocks that he has already seen, I don't know, right? To do that, we introduced the new edge called justification, which is basically the pointer to the all other blocks that I have seen. And that basically makes the perfect graph about my parents and the blocks that I have seen as a validator, and each validator send that information to all other validators, and eventually they construct a graph that will be the same for all of those validators. Right, guys. So once that is done, right, they call it as an agreement graph, right? And once the agreement graph is ready, right, is possible to calculate the decision weight. Right. So this decision weight can be used to make a decision to finalize the block and confirm the block's validity. We're not going to see how decision weight is actually being calculated. Okay, but overall, what happens is justification is plays important role in verifying all validators are conforming to the same protocol, basically, which is mandatory to be a validator on the CasperLabs blockchain. Right. So now let's go over this later by CBC Casper paper written by Daniel Cao, the mathematician from I think CSCD University. Yeah, he's genius. Right. So this paper is basically the proof of all concept, hypothetical proof of all concept implemented in CasperLabs blockchain. And some of the definitions that we already saw, like CasperLabs is partially synchronous network, right? Suppose the safety and liveness. So eventually all host or validator nodes will see the same graph eventually. Messages, justification, and validators, right? We already went over it, but it will take like hours if I go over all these definitions and things and proof. But I did understand all of this actually, right? So votes and weights. Basically, the way it calculates the decision weights, we have seen the theory, but this basically explains the mathematics behind it. Safety rules and blockchain and cost. Cost is the rule actually that we have just seen the last, the way all validated nodes come to the same DAG representation, right? While doing that, they come up with various subtrees and various decision weights, right? But they chooses the heaviest weight, right? So that's what the ghost rule about is greedy heaviest observe subtree, basically, to come up with the final decision weight, and all validator does the same thing basically. Right, let's have a look at the CasperLabs testnet demo. So I'm going to use this documentation to connect DevNet using Docker. So first of all, we need to create the account on CasperLabs Explorer. I already did that, so you just need to connect using your Google account and create the keys and then follow the steps. I have my account created. I already have the key, and I already downloaded my public and private keys, and I also requested some tokens from this. So you can see I already have some tokens. So they give you 10 million tokens. I will tell you where is my 10,000 tokens gone. Right, and so let's start looking at each component. So I already pulled the Docker images of CasperLabs node client and execution engine. Let me go over my terminal. So just to verify that, if I copy this, I can see I already have the latest node pulled, then CasperLabs client. So I already have the latest CasperLabs client, and the last one is execution engine. So yes, I already have each image is a latest image. I already created this directory and set up CasperLabs network locally. So if I want to see that, just start CasperLabs. So yeah, I created and CasperLabs node execution engine will be using this directory to put the logs and things. I already copied my private key and public key to this folder because we will be using that, referencing this folder while executing the commands. Right, so first thing we need to execute is execution engine. Let's run execution engine. But I think, yeah, so I already get that this conflict because it's already running in my machine. So you can see Docker PS execution engine is already running. So I have started it about an hour ago, it says. And to run the node, right, what we need to do is I think there is some things that we can understand here. So the node is going to run on localhost 4400 and 4405, right? And this is basically the Docker image node. What we need to see here is few things. So we are connecting to this CasperLab nodes, which is dev node at 4400 port. Yeah, I'm going to use my private key and public key. And the last is we are going to do auto propose more. So this node, once it starts running, it will start proposing the node automatically. Right, so I got another conflict because and the node is also running. I already started that, but if you are not running, it will start the node. And to check what the node is doing and which block it is, let me see the logs. Logs, it should be Docker logs. Okay, you can see I already synced the 866 blocks so far. If we go here and if we see the number of blocks that's available is 867, so it should have synced up to the latest block. Okay, let me do one thing. I can see if it tries to sync up automatically. What I do is where is my node is here. So let me kill this node and then try to run again. So this is I'm running node again, right? And let's see the logs. Trying to open the port, right? So it's trying to connect to the DevNet. Let's see, and right, so it's disconnected. Now, yeah, it's doing some sanity checks. CasperLabs, right? So one new block, it spawns the one new block. So start sync up the blocks. Right, so basically now we are on 867. So that is the latest block available on the blocks on Explorer. So our node is up and running and sync up with the blockchain basically. Right, so once you have the node and engine running, what we can do is send the bond request to on the blockchain, right, to start proposing the blocks basically to become a validator. I need to use my command using my private key and the public key. So I can send the bond request. I think I'm already bonded, so it won't do anything. It'll just give me this deploy, right? But if I want to create the new bond request, I should be unbound before this. I can deploy the contract. I already deployed the contract as well, so I don't think it will deploy the same contract. It might give me, okay, yeah. So it gives me that this invalid argument, right? Is because already deployed. So the previously deployed contract errors, let me show you here. Right, so let me go all the way top. I think I have deployed it here. somewhere. So yeah, I built this hello define contract, Rust contract, which is available on the repository here, and I followed these instructions to use the nightly build of Rust, and then basically build this hello define. It has given me in the wasm file hello, which I have deployed here. So the deployed was successful here. I used this hello wasm hello name.wasm file. Right, so once it is deployed, right, let me go quickly to down. This is node logs. It gives me the deploy hash, right? So I can query deploy hash using local client, and that's why we need this client. So let me run this command here. If I want to see the detail about my deploy, I can see here. Right, it gives me all information. Header account, what was the public key, which is my keys. If you go on account keys, and you can see ending with 650274, right? So that's my key. That's where I have deployed it. Who has approved, right? So I approved public key, and the processing results basically is who my parent hashes. So it's 2718, right? Ending with, so let's see the graph. So what I want to do is I will search for this deploy hash here. Okay, so I can see who is my parent, right? So yeah, 10,000 was detected because I have used the bond request using the 10,000 amount. All right, so let me see my parent. So parent is 2718 ending, right? So I get the same information in client as well, 2718, which is my parent. Justification ages, what was the state of all bonding, right? Some bonds and the signature. So that's it basically, guys. So this is how a transaction looks like, and if I want to look at this graph, right, that's where my transaction is on the DAG, right, and it says parent, and after that, like, so many transactions executed on my node as well. Right, I think that's everything related to the demo. Right, so let's go over a few last bits. Team, then GitHub repository, and developers profile. So to start with team, Medha Parlikar, the CEO, I have spoken with her many times, and I would say I found her like one of those CEOs who are very rare to find, in terms of business, legal, technology. She is so clear. I mean, she has given a clear demonstration of the technology, and you can also see her few videos on the YouTube and the way she is explaining. Pollard Zamfir is lead Casper architect and very well known for Ethereum Foundation. I've also seen some of the videos posted by Michael explaining the CasperLabs testnet. And one of the other guy I want to look at, the Daniel Kane. He is a mathematician, the guy who wrote Casper mathematic paper. So he has a very strong profile, and I think he understands what he's doing basically, right? Given the whole hypothetical proofs of the overall Casper Lab system, which is amazing. And I think they have quite a few, about how many, 5, 10, about 25 to 30 people full-time working on this project. Right, so let's go over their GitHub repository. Right, so I mean, you can see it's very active, developing the Casper Labs core. They have given some good examples for contract. So also we have seen this in the demo. right? You can just compile and deploy on the CasperLabs blockchain. If we go into the little bit detail about the code, so they have the separate components for CasperLab client, execution engine, and the node, right? The interesting thing here is they are using this continuous integration and build using the drone. And I mean, you can see there is let me open the Grafana. Yes, there you go. So this Grafana is basically continuous monitoring system. They have these nodes running, and this was the graphical interface about blocks received, deploy buffers, block downloaded, block proposed. So I think it's still trying to download. And they have a detailed integration testing for each components, which is definitely a very good and plus point. So let's go the developer's profile. I mean, it's very amazing. I would say when you can pick up any guy, right? Of course, you can see like very active person committing into the GitHub repository, the CasperLabs. If we see his commits, and this guy, amazing. I mean, it's very difficult to build this kind of GitHub repository, when you are like on the GitHub like since 2013 and very actively committing into the repository. If we see here's some of the commits. Good guys. So I mean that's enough for the team. Team looks very solid in terms of GitHub. I would say. I want to go like overall opinion about the CasperLab project. I would say I found it a very unique project, to be honest. And it seems the promises that they're making is very honest, and it can be achievable given the concurrent engine with the sharding. I say they are aiming to disrupt this blockchain space to the next level, without compromising security and the decentralization. I would say it's a solid project, backed up by the top-notch team of developers and leaders who can make this project possible. The development process they are following using continuous integration and build and integration test is solid. It's some of the best practices that they are working on. So I think that's it, guys, for today's demo on the technical review of CasperLab projects. So again, just all of this is my personal opinions, not a financial advice. So do your own research before making any decisions, guys. Thank you for watching in Code We Trust. I will see you again maybe next week with some great projects review. Thank you.
Steve and Dave use eToro to invest in the financial markets. Steve does research on global investment opportunities. Dave does research on how to become a level 60 wizard. Steve follows the feed for the latest market news. Dave follows the feed for the latest cat videos. Steve has a watch list for promising investments. Dave has a watch list too. So why is Dave just as good an investor as Steve? It's because Dave used eToro's copy trader to automatically replicate Steve's trading activity. Whenever Steve makes a trade, Dave does too. Yes. Trade like a Steve with eToro, the world's leading social trading platform.
Count for what I really think. Being in the space, I learned to see.